Welcome to GM Med School. I am Dr. Madnani, and today we'll be learning about a medical device used to monitor the heart's electrical activity known as the electrocardiogram. So, what are you waiting for? Let's learn. So, what is ECG? An electrocardiogram, commonly known as ECG, is a rapid, reliable, and cost-effective method to aid in the diagnosis of cardiac pathology, including ischemic and arrhythmic events. ECG is a recording of the heart's electrical activity as a graph over a period of time. The graph shows the heart's rate and rhythm, and it is a safe test and there is no risk of being electrocuted. ECGs are the primary clinical tool to measure electrical and mechanical performance of the heart and works by detecting and amplifying tiny electrical changes on the skin that occur during heart muscle depolarization. This is then formed into a graph that shows several waves which correspond to the different electrical and mechanical events within the heart, and the changes in the waves are used to identify problems with the different phases of heart activity. The last few years of the 19th century witnessed the rise of a new era in which physicians use technology along with classical history taking and physical examination for the diagnosis of heart disease. The introduction of the electrocardiograph provided objective information about the structure and the function of the heart. In the first half of the 20th century, a number of innovative individuals set in motion a fascinating sequence of discoveries and inventions that led to the 12-lead electrocardiogram as we know it now. Dutch doctor and physiologist Willem Einthoven, who won a Nobel Prize for crafting the medical tech masterwork, was building on a long history of tracking heartbeats that began in the late 1700s. A turning point came in 1872 when Gabriel Lippmann came up with a gadget called a capillary electrometer, which could measure the voltage changes on the body's surface produced by the pulses of the heart. A.D. Waller, using Lippmann's invention, captured the first actual measurement of a heart's beating in 1887. Sir Edward Schaffer of the University of Edinburgh was the first to buy a string galvanometer electrograph for clinical use in 1908, and the first ever electrocardiogram machine, built by Einthoven, was introduced in the United States of America in 1909 by Dr. Alfred at Mount Sinai Hospital in New York. So, how is ECG performed? An ECG allows your doctor to see how well your heart is functioning and can use this test to diagnose any problems with your heart or to monitor the problem already known. The test usually takes about 5 to 10 minutes, and small discs known as electrodes are stuck to your skin. 12-lead ECG placement guide shown here. They are put on the chest, arms and legs. The doctor will ask you to lie down while the electrodes monitor the heart and may ask you to hold your breath at several stages in the test. The electrodes are used to detect the electrical waves produced by your heart. This is then recorded on a chart and the electrodes are removed from your body. The electrodes can detect the speed of your heartbeat, rhythm and strength of the electrical signals that trigger your heartbeat. There are several parts of the ECG. Dr. Einthoven innovated the ECG for clinical use by refining the electrometer and outlining the PQRST waves. The P wave is known as the atrial depolarization wave. The first wave on an ECG is the P wave, and this indicates the atrial depolarization in which the atria contract. The P wave is the first wave on the ECG as the action potential for the heart is generated in the sinoatrial node located on the atria, which sends action potentials through Bachmann's bundle to depolarize the atrial muscles. Fluctuations in P waves can indicate problems with the potassium ion concentration in the body that will alter nerve activity. A missing P wave indicates atrial fibrillation, which is a cardiac arrhythmia in which the heart beats irregularly and in turn prevents efficient ventricular diastole. The PR interval represents the time taken for electrical activity to move between the atria and the ventricles. The QRS complex includes the Q wave, R wave, and S wave. These three waves occur in rapid succession. The QRS complex represents the electrical impulse as it spreads through the ventricles and indicates ventricular depolarization. The ST segment is an isoelectric line that represents the time between depolarization and repolarization of the ventricles. This is also known as contraction. The T wave represents ventricular repolarization. And finally, the QT interval represents the time taken for the ventricles to depolarize and then repolarize, hence the contraction interval. The electrocardiogram has been used as a cardiac diagnostic for more than a century now, and testing systems are evolving to meet modern technological demands. In today's increasingly mobile and digital world, ease of use for streamlined technology is in high demand. There have been various advancements in ECG technology with more compact and mobile ECG monitoring systems being introduced. These can be used anywhere, whether it be at the hospital, clinic, or even in the comfort of your own home. Many handheld devices are accessible these days. The new generation of devices are inexpensive or even disposable and are much easier to use. With the elimination of electrode wires, devices are simply stuck on the patient's chest. Some new devices interface with mobile phones to eliminate the need for an external base station hardwired in the patient's home. These devices, combined with consumer-grade app-based ECG monitors that interface directly with a patient's smartphone, will likely result in widespread expansion of basic ECG monitoring and represent a novel method for patient engagement in cardiology. This has been Dr. Madnani, and I certainly hope I have provided you with a valuable insight into the topic of ECG, and see you next time on GM Med School. Goodbye.